Our next speaker is Kim Anderson from North Carolina State University College of Textiles, instructor, PhD student presently. Her research is in medical textiles and electronic textiles. The topic is color discharge and printing without the use of an illuminating dye.
Okay, in this experiment, we tried to produce a discharge printed fabric without using an illuminating dye. In traditional discharge printing, designs are produced on a pre-dyed fabric. The dyed fabric is printed with a print paste that contains a discharge agent and the illuminating dye. The discharge agent destroys the ground while simultaneously the illuminating dye imparts color into these areas. Using the illuminating dye makes the process somewhat difficult. So if you could eliminate it, you could potentially have a simpler and less expensive process. There's some very unique aesthetic advantages that we associate with discharge printing. You can get large areas of dark ground with the printed designs in very light, delicate colors. We can get very intricate patterns with crisp, sharp edges. And these aesthetic advantages are really hard to achieve with other processes such as rotary or screen printing. There are some disadvantages. It requires specific equipment. There's dye waste, because all that dyed ground that you're destroying goes completely down the drain. Some dyes are difficult to destroy. Therefore, there's always a certain amount of preliminary laboratory work, and then times and temperatures are crucial during the discharge process. Now, most of these disadvantages can be directly attributed to the illuminating dye. So if you could eliminate it, as I said, it would be a lot simpler. The most common illuminating dye used on cellulosic fabric is bat dye. And during printing, the discharge agent not only destroys the ground, but it converts that bat dye to its soluble form. At that point, it's paramount that the fabric undergoes a steam treatment, because you want to swell the cellulosic fiber so that bat dye can easily diffuse into the fiber. And then you treat it again so that bat dye converts back into its insoluble form, and it's fixed into the fiber. If you could eliminate it, you could possibly use a dry cure system. And times and temperatures during the process wouldn't be so crucial. So we looked at partial destruction of the ground shade. Instead of taking that ground shade to white and using the illuminating dye as imparting color, we wanted to take the ground shade to a aesthetically appealing color. And we did this, and the process did prove to be less expensive and a simpler process. Basically, there were two parts to this experiment. First, in the preliminary trials, we had to evaluate single dyes. As I said, we wanted dyes that would discharge to bright colors. Then when we evaluated the single dyes, we did some different dye combinations with selected single dyes. After that, in the final trials, we took the combinations that we chose, and we dyed yarns, and we put them in various pile constructions and discharge printed them. The preliminary trials we did on 100% woven sateen cotton fabric. We chose 14 different reactive dyes. Reactive dyes come in really bright colors. Their wash fast is excellent, and they are really good dyes to discharge. And then we looked at 3 different discharging agents. We looked at vinyl sulfone and monochlorothiazine as the reactive classes, because those are ones that are most appropriate for discharge printing. We chose primary colors, blue, red, and yellow, as well as a turquoise. We looked at more than one blue or yellow or red, because we wanted to evaluate subtleties such as a bluish red versus a yellowish red. We chose 3 of the most common discharging agents used to discharge cellulosic fabric: sodium formaldehyde suboxalate, zinc formaldehyde suboxalate, and thiourea dioxide. The print paste contained water and guar gum. Guar gum is a thickener, and it's stable. The viscosity is stable with the discharging agent in the print paste. We also use urea because even though we weren't using an illuminating dye, so the moisture wasn't as important, you still need a certain amount of moisture during printing because you want that cellulosic fiber to swell so the chemicals can get in. So urea lowers the rate of water evaporation from the fabric. So we needed urea to have a little more moisture since we were using a dry cure process. We cured the fabrics at 165 Celsius for 4 minutes, and then we rinsed them in cold water and wash and tumble dry. We evaluated the single dyes before and after discharge printing, 3 different methods of visual interpretation, LAB, coordinates, and delta E, and reflectance curves. Now the visual interpretation is exactly what it sounds. We looked at the fabric and just documented the view. LAB coordinates, L measures the darkness or lightness of the fabric. A looks at the greenness or redness depending on if it's negative or positive, and the B, depending on the sign, measures the blueness or yellowness. And delta E looks at how the fabric changed. So if you had before discharge you had a red fabric, and then after discharge you took it to white, you'd have a high delta E. However, if the discharging agent had no effect on that dye, the delta E would be close to 0. Reflectance curves any colored object, in this case dyed fabric, will reflect waves of its hue and absorb waves of its complementary hue. So by measuring the reflected waves, you can get a very scientific interpretation of the color of that fabric. In reality, this was a master's thesis, and the LAB coordinates and reflectance curves turned out to be purely academic. I chose the single dyes just from visual interpretation and what I liked, but it was interesting process. Of course, we also had to look at physical properties, light fastness, wet and dry caulking, and all the dyes passed with either a 4 or 5. They all passed the ASTM standards. After the single dyes, I chose a red, yellow, and blue. I just thought those had the most potential for combination dyes. And did 7 different combinations, 3 greens, 1 purple, and 3 orange. From these, I went through the whole process again. I dyed the fabric and then discharge printed it with the 3 discharging agents. And from these results, I chose 2 combinations, a green and an orange, and they both discharged to a really bright yellow. And I also chose a single dye, a Procyon green. It was a blue-green, and it discharged to a really beautiful purple. So I chose those two yarn dyes and put in the final trials. I also used a vat dye and a bleached yarn because they were unaffected by the discharging agent. And I thought if I could strategically place them in certain areas of the fabric, it might add some textural interest and it might be just interesting effects. So we'll see. Eventually, well, I dyed the yarns and then I constructed 11 different pile constructions. I used a single knit pile. I wanted to use a velvet loom or velvet construction, but we don't have a velvet loom at the school. These are the fabrics before discharge printing. The first one is a chevron. Fabric number 1 is a chevron sort of pattern. Fabrics number 2, 3, 4, and 5 have the vat dye in the ground. Fabrics number 6, 7 just are totally comprised of reactive yarns. 8 had the bleached yarn in the ground, and then 9, 10, and 11 were totally constructed with reactive dyes, either the combination or the single dye. I did, as you notice, it's 3 different patterns. There's a chevron, a block pattern, and then the vertical stripe. I chose 2 different print patterns of botanical motifs. One was a sort of a bold scattering of leaves, and the other one was slightly more intricate. I just wanted to evaluate if there was maybe a bolder pattern would be more successful than the more intricate pattern. It printed a total of 21 fabrics, and I ended up just using thiourea dioxide because the other, the sulfoxylates just took most of the dyes to white or a real dirty color, and thiourea dioxide was the weakest, and it excuse me, took the dyed yarns to a really nice, bright, aesthetically appealing color. By nature, a aesthetic evaluation just varies from one person to the other, but I deemed fabrics unsuccessful if the colors were muddy, if the designs were hard to discern, and the ones that were successful had very appealing colors, and the designs were very easily discerned on the fabric. This one I thought was fairly unsuccessful. I only printed it with the bold leaves because I thought if it didn't work with that, it wasn't going to work with the more intricate pattern. I think there was just too much going on. This one doesn't show up very well. A lot of these are from a scan. I have better pictures if anybody's interested after. This one actually was quite successful, especially with the orange. It had the vat dye in the ground. It was unaffected by the discharging agent. But I thought it was pretty interesting. The green isn't as successful as the orange one. This is the same fabric, the combination dyes on the pile and the vat dye in the ground, just using that bolder leaf pattern. This had the single dye in the pile that was the blue-green that went to purple, and then it had the vat dye in the ground. And it's quite nice. It's not showing up very well because it's kind of light. This one was, the vat dye in the ground, just there was too much run through, so you lost the pattern, and it was quite unsuccessful. This was really nice. It had the top one has the green combination dye, and the ground is the orange combination dye, and then the bottom one is the green single dye in the pile and the orange combination in the ground. But you're really getting, well, the bottom one you're starting with the 2-color and taking it to a 4-color. It's really a nice fabric. And the same constructions using the bolder leaf pattern. This is the combination green dye in the pile with the bleached yarn. Again, a very successful discharge print without use of the illuminating dye. That was deemed successful. This one was as well. This one actually, the pile had two yarn dyes that were both combinations, and there's just a lot of complexity in this, the top fabric. It was very, very interesting. And then the same fabric instructions with the boulder leaf design. It is possible to produce a discharge print without using illuminating dye. You can do this in a dry cure process, and you can certainly produce aesthetically appealing printed patterns. There are some disadvantages. One being you need preliminary work. There are only certain dyes that will discharge print, and so therefore you get these beautiful color cards that are showing you the end colors for the next year and a half or something, and you might not be able to use them. You are limited because not all dyes will discharge to a aesthetically appealing color. So I think that's it. Thank you. Anybody have any questions?
Any questions? I have a question.
Okay.
You have selected, from what I understand, you have selected dye stuffs that will discharge and others that will not. Is that how this was done? Maybe I missed the speech.
No, go ahead. Could you repeat that again?
Essentially, some of the dyes that you had were dischargeable, the others were not, and that's why you had the ground that survived and the other did not.
Some of the dyes were discharged. Well, the combination dyes, there was an orange and a green. Let's take the green. It was a combination of a blue and a yellow. The blue was discharging, leaving the yellow. So the yellow was unaffected. In the case of the single dye, that was a really neat one because you had a single blue-green single dye, and the discharging agent affected it and take it to purple. So they, instead of discharging to a white, they were discharging to other colors, lighter colors.
Very good. Any questions?
One of the most problems with the discharge printing is the drawback on the mechanical properties of fabric. Due to the cutting base has a high reducing agent like zinc aggregate, acetylene dioxide, thiourea dioxide. All of this material may make some reduction on the backbone of the fabric, so there is a drawback of the mechanical properties of the fabric. How can we solve this problem in the discharge?
What exactly is your question?
The cutting base in the discharge printing maybe cause some disadvantage in the mechanical properties of fabric. So
the printing process is affecting the mechanical properties of the fabric?
No, the cutting base, the thickening base that has a reduction, reducing agents or discharging agent, chemicals using for discharge may cause some problem in mechanical properties of fabric.
Did you do any testing on strength loss or anything like that?
No, but for something like an apparel, this process could be used for upholstery or apparel, but apparel, the strength properties aren't. I didn't detect any strength loss. Thiourea dioxide is very weak. I don't think that the fabric was I didn't detect anything. Usually you can tell just by handling and feeling a fabric. I didn't find that true. You could do some, tests. I think maybe an abrasion test, you might find some things.
It doesn't notice in the high weight fabrics, but in the low weight fabrics, it's very effective.
Yeah. Well, this was a single jersey pile fabric, so it did have some strength to it. Mm-hmm. But if you were doing like a voile, a very lightweight fabric, you might see some strength loss. But it wasn't. Sodium sulfoxylate was very strong, and I can see that having a detrimental on the mechanical properties of the fabric. But in this case, the thiourea dioxide, it was a low percentage of it as well in the print case.
Thank you. Question? If you use the microphone.
Why pile fabrics?
Pardon?
Why pile fabrics?
Well, you could use dobby weaves and upholstery. I actually think this has a lot of potential to do on different types of constructions. I wanted pile fabrics because I really like the idea of the grin through, of using a batt dye that was unaffected and having a grin through. So I wanted to use like a velvet with a strong grin through of a batt dye.
So you have no problems with pile penetration then?
I hand printed them, and yes, you would probably have to, certain areas where the ground was a reactive that was being affected by the discharging agent, yes, there were some areas, it wasn't totally even. So you would have to address that maybe with wetting agents or using a batt dye in the ground.
And then my final question, did you eliminate haloing completely?
You couldn't really tell because of the pile,
Yeah.
and that was another reason of using the pile. I didn't see any of that because there was so much going on with the pile construction. And also when there was 2 yarn dyes in the pile construction, it was even harder to detect anything.
Thank you.
So any additional questions on the board?
You used in your printing is 6% guaidan. This means you used a high viscosity paste. So this high viscosity paste used for a sharp lines, not a wide area. Is it you intended to do that high viscosity paste in your design?
Yes, and because it was pile, yeah, suggested percentage.
Obviously, we have a collaborative effort here. Yes?
I'm coming back to the question my friend was asking about the strength of the fiber. Because I think that it would have been very helpful if you measure tenacity of the fiber or strength of the fiber after this reduction treatment. Because during the discharging reaction, reduction treatment could have a deteriorating effect on the fiber. And another point, the fastness of this discharging effect, because sometimes the discharging effect can be having some yellowness after that. So the fastness itself is very important against many factors.
What kind of fastness?
Fastness of the treatment.
Light fastness?
Yeah, discharge. No, the discharge. Yes, against light. That's right.
We
Against
tested
light,
them.
especially against light, because sometimes sunlight makes some yellowing effect after the discharging treatment.
Right.
So these are the 2 questions.
Well, we tested them with light and wash fastness, and they passed according to the ASTM standards. As far as the strength, I really do say I've done a lot of experimental work and printing, and I wish I had samples of the fabric. There's really no deterioration of strength or the yarns. I take that as a good point, though. You could do some
I think it is worthwhile doing
laboratory
it.
properties, yeah.
And you can do also, instead of mechanical tests, you can make chemical tests which give you indication about the strength. Some other chemical methods to determine the strength or tenacity.
Rheological type test.
Yes, many.
Hydrolysis or oxidation reduction.
Yes, solubility tests. Yeah, thank you.
Thank you.